Good day and welcome to Maths and Physics with Mr. Simons. Today's lesson on application of calculus, September 2016, Eastern Cape paper. We're looking at rates of change. Right? So, they say a water tank has both an inlet and an outlet which regulate the depth of water it contains. The depth D in meters is given by the function dt equal 3 plus half t squared minus a quarter t cubed, where d is measured in meters and t is measured in hours. So my time is hours and t is meters, starting from 8 o'clock, right? So we're starting specifically at a time. Calculate the depth of water at 8 o'clock. So 8 o'clock is at the beginning, so that time there is 0. So water hasn't moved, so at 0 hours, how deep is my water? All right, 11.2. Calculate the rate at which the depth is changing at 11 o'clock. So when I see the word rate, I'm going to do first derivative. Changing at 11, so that's 11 minus 8, that's 3 hours later. Right, based on that answer there, if I read 11.3, what happens to the depth of the water at 11? So we want to know what that answer is telling me about the water at 11. 11.4, at what time will the inflow of water be the same as the outflow? Right, so the rate in must equal the rate out of the water. So let's look at the first question. So calculate the depth of water at 8 o'clock. So that time is 0. Remember, we're starting at 8. So we're going to take the 0 and substitute it wherever I see t. Alright, so d0 equal 3 plus half times 0 squared minus a quarter 0 cubed. So that becomes 0. So my answer is simply equal to 3 meters. Right, so at 0 hours, my water is 3 meters deep, which is quite deep. More or less 2 short people standing on top of each other. That's 1.5. Second question, calculate the rate at which the depth of water is changing at 11. So rate, I'm going to have to find first derivative. Right, my time, 11 minus 8 when I started equal 3 hours later. Right, so for rate, I need to find first derivative of the equation that appears here. All right, so as I said, my first derivative, 2 times half, gives me 1. 2 minus 1, 1. 3 times 1 gives me negative 3 over 4. 3 minus 1, 2. So my first derivative, remember first derivative of constant 0 is 1t minus 3 over 4t squared. But we want the rate at 11, so that is 3 hours later. So in the place of t now, I'm going to place 3. Alright, so there 3. 1 times 3, 3 over 4 times 3 squared. 3 squared gives me 9. 9 times 3 would give me 27 over 4. So I have 3 minus 27 over 4. As I said, 3 minus 27 over 4. And that simplifies to minus 15 over 4 meters per hour. Right? So every hour, that's how many meters it drops. Because it's negative, that's why I said drop. It means the water is flowing out, it's decreasing. Alright? So, next question. What happens to the depth of the water at 11 o'clock? So, the first derivative, 3 hours later, was minus 15 meters per hour. I almost said miles per hour. Meters per hour. Alright, so in short, that means the water is decreasing because of the negative. It's becoming less. Next question. At what time will the inflow of water be the same as the outflow of water? So we have dt equal 3 plus half t squared minus a quarter t cubed. So rate of water going in, rate of water out. So automatically we have to find first derivative. Alright. So my first derivative, again, remember first derivative of 3 equals 0. 2 times half would give me 1t. 3 times negative 1 over 4, 3 times 1 gives me negative 3 over 4 t squared. Right? So, equate that equal to 0. Right? Because the water going in and the water going out is the same. So, if I subtract the 2, they would give me 0. Right? From that 2 now, I can take out the common factor there. I assume you can see. Minus sign on either side, I can take out t. So, if I take out t as a common factor, Okay, it's first multiplied mathematically. So 4 times 1 would give me 4. That then becomes minus 3t squared, and 0 times 4 is 4. So instead of still working with the fraction, I multiply the denominator away. Right, yeah, that's still taking time to get used to the system of showing the next answer, because sometimes, yeah, my brain takes a different route to solving a problem. But yeah, you'll be strong as long as you understand what I've done. So again, there I multiplied everything by 4. So 3 times 4 is 12, but divided by 4 still gives me 3. Ne? 0 times 4 stays 0. So I have 4t minus 3t squared. And now if I take out t as a common factor, I'm left with 4 minus 3t. So there t came out. 4t divided by t gave me 4 minus 3t squared divided by t gave me minus 3t. Right? So 4 minus 3t equals 0. So t equals 0, or t, there if I take 4 across, it would become minus 4 divided by negative 3. T equals 4 over 3. Right, so at what time will the inflow of water be the same as the outflow? At time 0 or at time 4 over 3? So 4 over 3 times 60 seconds. Remember, we're working with hours. So 60 minutes in an hour. So 60 times 4, 240. Divided by 3 gives me 80 minutes. And 80 minutes equals 60 minutes, which is 1 hour and 20 minutes. So 1 hour and 20 minutes. Right. So that means at 8 o'clock, my flow of water going in and out would be the same, or at 20 past 9. An hour and 20 minutes later would give me 20 past 9. So hope you understand, I hope you follow. I'm trying my best to help you. Please leave a like, share with somebody. God bless. Bye.